to drop the presentation tonight. Welcome, it's so exciting to see so many faces here tonight. If this is your first time at Ocean Institute, welcome. We are a 501c3 nonprofit that is dedicated to ocean and maritime education. We use our mission of using the ocean as our classroom to inspire children to learn. And we are really excited to fulfill that mission with you all here tonight, learning from an incredible speaker. If this is not your first time at Ocean Institute, welcome back. It's good to see you. We're excited to have you back. Tonight is part of our Distinguished Speaker Series. Our Distinguished Speaker Series is very generously funded by the St. Louis Endowment. Let's give a huge round of applause for our funders. And tonight's delicious food and beverages were generously funded by Canopy Martins. Let's give a huge round of applause for them. Distinguished Speaker Series are an incredible series we do to continue lifelong learning on the first Wednesday of every month. So if you have fun tonight, please join us on the first Wednesday of every month throughout the year to continue your learning. So I know you all want to get on to the lovely Zadra. So without further ado, I will welcome up our President and CEO, Wendy Lovell, to the stage to introduce Chris.
Hello. Hi, welcome. Sarah gave you the warm welcome and grand introduction. This series is sponsored by the Nicholas Endowment. This night is very, very special. We're so glad to see such a large group here. I do want to see by show of hands, whose first time is it to a distinguished speaker event? Well, like Sarah said, we welcome you. For those who have been here before, welcome back. I'm very excited. I'm our presenter, Chris Zadra, probably 5 years ago. I think maybe 10 inches ago, because he seems to have grown since I met him. But I had the pleasure of meeting him. He was an engineering student at Lehigh University, and he had an interest in drones. We love his story because it's so inspirational for children. He took his passion for drones and made a career out of it. Sorry, it's me. Made a career out of it by connecting. Sorry,
It's finicky.
we're going to use my teacher voice. Can you all hear me? Okay. So he used his passion for drones and connected it to a really interesting and important cause, which is great whale research. So with the Ocean Alliance and the Drones for Whale Research Program, he began his career studying whales. And I would say, be very careful tonight. If you have allergies, don't sneeze. And you'll find out why that's important as he goes through his presentation of the snot box. So we're very privileged. I want to say again, being able to do this, our role as an ocean education provider is to connect research to the public. Usually we have small children here by day, but to bring in adults at night and have the same information presented, the Distinguished Speaker Series gives us the opportunity to present at your level. So I hope you will enjoy. Some of you laugh. I know what that means. At your elevated level. So once again, we welcome you, and I would like to now welcome Chris on stage. So enjoy.
Hello, everyone. I'm going to stand on this side. iPad over there can see most of this. Thank you all for coming. It's really exciting to be here. I grew up doing summer camps here, so it's pretty wild to be here up on stage and to see so many friends here. Yeah, really excited to share some of the work that I do, and hope you all find it interesting. There's lots of cool videos and interesting stuff to share with you guys. If anyone has any questions at any time, feel free to just interrupt. If I don't see you, throw something, stand up, do whatever, it's okay. And yeah, so I'll just jump right into it. Cool, it's working. So I'm from Ocean Alliance. We're a small nonprofit based in Gloucester, Massachusetts, 30 miles north of Boston. We work out of this lovely historic building that we are sort of renovating and creating into an ocean innovation center is what we like to call it. We have our own little research boat and docks and a national marine sanctuary right out the harbor, so it's a great place for whale research and developing some new technology. Our organization was founded by Dr. Roger Payne, who's well known along with his wife, for sort of discovering and sharing with the world that humpback whales sing songs. The reason I'm bringing this up is there's a couple sort of historical. I don't have a good teacher voice. That's it? Okay. There's some history with the organization that. The battery? I'll play you some whale songs in the interim. Test. How do you want to do on the playing audio? You just get going. So, is it playing? So Roger did all this original work with recording humpback whale songs across oceans, across decades, and he released this album in 1971 called Songs of a Humpback Whale, which was sort of a really important movement in sort of humans and their empathy for other species. And Roger having an ability to create this empathy for other species really galvanized sort of the start of the Save the Whale movement and the commercial whaling, and just realizing the importance of trying to draw a line between human activity and how we affect other species. It's a really cool kind of legacy that our nonprofit was founded on, that we try to carry forward in a lot of the work that we do now. And if you want to check out some of these songs, we're actually going through the process of digitizing all these reels right now. So you can look up, just search Ocean Alliance on SoundCloud. There's a bunch of cool recordings from the 70s in Hawaii and different whale songs that are really fun to listen to. Next one. So moving into sort of the 90s of the organization, we had this research vessel called the Odyssey, 93-foot catch. Sailed around the world multiple times doing long-term research with mostly sperm whales, but also it was a platform for facilitating testing new research methods, new ways to sort of collect biopsies, to study whales at night using thermal cameras, and also filming IMAX movies and Discovery Channel documentaries. This was kind of what set us apart from other organizations, and kind of what our bread and butter was using media for conservation and also facilitating cool research, new science, new technology, new methods. But eventually that boat, they owned it for 20-something years, recently sold it sort of 2015, got too old, too expensive, so we downsized to a building. And now we own this fantastic site, which is where we are today, and still, keeping those sort of ideologies of media for conservation and developing new technology out of this lovely facility. So that's a little bit of history about who we are, and now again, I'll talk about why we want to study whales. It's important to try to draw this line between humans and whales, and how whales help us and how we can help them. Whales are actually sort of ecosystem engineers. They're really important for keeping the oceans healthy, and then in turn, the ocean actually plays a massive role, the largest role on mitigating our climate and keeping us healthy. The way whales are sort of helping to engineer the oceans is by eating a lot, and when you eat, usually you have to poop afterwards. And all of that is nutrients that the whales are moving around the ocean, bringing up from depth to the surface. And what that does is actually fertilizes phytoplankton, which is capturing carbon out of the atmosphere and also providing food for krill and smaller fish, that is then whale food, and completes the whole cycle. If you want to dig into this, everyone on their seat has an article from the IMF came out a couple years ago that goes into depth on how this whole cycle works, sort of the value of a whale in terms of carbon capture, and it's really interesting. There's some incredible numbers there on how valuable whales are. So where we fit into this is we want to study, are whales healthy? And if we have healthy whales, then we have healthy oceans. We have healthy oceans, we have healthy humans. So the trick is, how do you tell if a whale is healthy? That's what we see most of the time when we see a whale from a boat out on the water. Looks the same anywhere in the world. It's a floating thing in the water. It's kind of hard to tell if it's healthy or if it's stressed, if it's eating enough. So we have to come up with sort of novel tools. Most of the time, if you want to know if a whale is healthy, you need a physical sample, like a biological sample. And then you can dig into that and say, you know, what are the hormone levels, or are there toxins in the blubber or something. Recently, obviously, there's been development with drones. So drones are providing this new perspective on these animals. We can get this aerial perspective. This is an example of how we're using drones to measure the body condition of whales. So this is measuring the length and the width of a whale. We can tell how fat it is. We can compare it to other whales around the world or in its population. So at Ocean Lines, we hopped on the drone thing pretty early, and we realized, this is a tool that's going to become, very important and pervasive in the sort of marine mammal research industry. So we started our Drones for Whale research program, of which we have sort of three main pillars that we like to try to fit all of our projects into. Novel tools and methods, which I've been talking about. Non-invasive health assessments, which is collecting these biological samples. And then democratizing science, which is not making a tool that we're the only ones that can use. We want to make things available, repeatable. We work in some pretty remote places around the world with some pretty amazing research teams, but it might be hard to get resources or tools into there. So a lot of times we'll leave everything we come with so that they can then continue on the work without us.
Chris?
Yeah.
What's the current size of that whale that you had shown on the slide before?
What was the length of that whale? It was 23 meters. The width, good question. Probably 3 meters, so like 12 feet wide. It's a blue whale, so it's the largest animal on the planet, so it's pretty big. So our first sort of breakthrough, if you will, with drone technology and our Drones for Whale research program, we aptly call SnotBot. So SnotBot is collecting that biological sample, but the cool thing about it is we don't actually have to physically interact with the whale. So we don't have to get a biopsy, we don't have to get close up to it to collect a sample. We're getting all this physical biological data from the lungs of the whale when it comes up to the surface and exhales. We call it SnotBot because it looks like it's sneezing, but what it really is, it's body temperature air inside the lungs of the whale. The technical term is exhaled breath condensate. And some of it is seawater, but a lot of it is actually they just blow this huge amount of air rapidly out of their blowhole into colder atmospheric air, and it condenses, and that creates the little mist, the blow or the spout that you'll see. And we can fly through that with a drone and collect that. So this will be just a run through of how it works. So we'll Velcro dishes on the drone, take off from the boat, collect a sample from the whale. A lot of times we can tell we got it because we're covered in snot on our camera. Bring the drone back to the boat, remove the dishes from the drone, and then those get swabbed down and sucked up and put into a little crowd outlet, then get shipped off to a lab, and they can analyze it for all sorts of different stuff. So some of the stuff that we're looking at in the blow, there's sort of three main areas that are sort of the current research is going in. DNA, which is sort of who's who, is it male, is it female? Hormones, which is it stressed? Can we identify if it's pregnant? And then microbiome, which is similar to DNA, but it's the DNA of the bacteria and viruses and little critters that are actually living within the lung of the whale. So the microbiome has actually been, jump the slide. Over the last 6-7 years, we've worked with 10 different species, collected 600 plus blow samples. We've been all over the world doing this, collaborating with different teams, and just trying to collect as much data as possible to really be able to dig into this sort of new scientific paradigm. There's lots of groups all over the world now using drones to collect blow samples, and we've shared our protocols with, 24 different, 30 or 40 teams probably. I'll just play that again, I'll run through the species here. That's a southern right whale. These are gray whales. Those are Argentina, this is Mexico. There's an orca in Alaska. This is a humpback in Dominican Republic, I believe. There's a blue whale in Mexico. That is a fin whale, I think, in Massachusetts. Sperm whale in the Azores. Brutus whale or a sei whale. That's the Brutus whale. They're very similar. And the Azores also, and a bottlenose dolphin in South Carolina. So toothed whales, baleen whales, big whales, small whales. And we've developed this sort of really broad data set. And the first thing we did, I'm not a biologist, but I'll give you like the overview of this. This is just comparing broadly the difference in microbiomes between toothed whales and baleen whales, and just showing that there is separation, there's uniqueness between different whale species. Even the baleen whale, so we have a blue whale in the middle and a humpback whale, they all sort of group in their own environments, which is interesting, probably seems like common sense, but this is stuff that sort of no one had ever done before. So it's interesting to publish it, get it out there, make it sort of fact, if you will, in the scientific community. And then we looked into sort of more specific, when we narrowed it down. So the year after, we did repeated samples on individuals. So we did this off the coast of Massachusetts, where, similar to here, you can identify whales from, these are humpback whales, you can identify them from the patterns on their fluke. And the whales off the East Coast have been cataloged since 1970 something, so they're really extremely well known. We have lots of life history on these animals. And the idea is that we're adding to the puzzle. So it's hard to know anything just off the microbiome alone, but if we can sort of combine it with life history of the animal, the photogrammetry, which was measuring the size and the growth of the animal that I showed before, and sort of all these different health metrics, it's helping create that baseline understanding of, is this a healthy whale? Does this microbiome show anything different? So this sample is just showing that these individuals come together in their own individual microbiome sections, areas. Yes?
In the time you've been doing this, have you noticed any changes in the population of these various whale species? I've heard that population is increasing.
I don't know the answer to that. I think certain populations, I think humpback populations out here are doing really well. I know in the late 80s, early 90s, the population of humpback whales in Hawaii was in the few thousands, and now it's in the 20,000 range. But it's really the spread between different populations. We did a project with humpback whales in the Arabian Sea, and there's 80 of them left there. There's different species are going up, some are going down. It really depends on the environment, and there's some other endangered species we'll get into that obviously aren't doing so well, but
Chris, are those the names of individual whales?
yeah, these are individual whales. So the pink one that we had the most samples from is clamp. There's clamp, gorge, dross, freckle, jabberoo, mogul, pinball, ravine, and ridgeline. It's beyond my understanding of biology. They're ASVs. It's basically different genuses of microbiomes, and it's a weird statistical thing where it'll put it on a map based on how different it is from everything else. So that's a little bit about Snowpop. That's one way of collecting data from a whale to try to tell if it's healthy. But that's sort of, literally surface level. A whale spends a lot of its life, if not most of its life, beneath the surface. So again, see a whale. Is it feeding? Is it traveling? Was it socializing? What was it just doing before it came up to the surface and took a breath? And how do we get that data? The way we get that is with tags. A little spoiler there on some tag video from a feeding blue whale. So tags have been around for a long while, actually, for 20 plus years. Some of the first tags are these tags known as D tags. Were developed at Woods Hole. There's different types of tags, but we're going to be talking about suction cup attached tags. So these are temporary tags that stay on for a few hours to a day. They collect really high resolution data. They do, imagine like a Fitbit on a whale or your iPhone on the back of a whale. It's acoustics, acceleration, heading. You can get speed, depth, obviously, and time. And you can sort of recreate the whole behavior and sort of history of that animal while the tag was on it. And these are also what are known as archival tags. So all the data is stored on the tag, because we're talking like tens of gigs or hundreds of gigs of data. And so the tags will release at some point, and there's GPS and radios and methods to find them afterwards, so we have to go pick them up if we want to get the data. So this is an example from a camp tag. So it's slightly larger tag than that. We'll play the video. This one has sound, but we don't need it. But hopefully this does something up. So this is just showing the type of data that these tags are collecting, and I'll explain some of it. So we have sort of raw data numbers on the left here. We have a graph of the data below. We have the orientation of the whale at the top there. And we're on the back of a blue whale, but it's really deep and dark, so we can't see anything yet. But we will shortly. So this green line here is the speed of the whale. This blue line is the depth. Those are the two most interesting ones. And what we see is it's going really deep. It's about to speed up and get shallower. And at the same time, it's going to tilt vertical. So we see it now looking straight up. We can see the light. And there's actually this ball of krill, this whole school of krill, that this whale is going to lunge through. So it's going really fast. It just opened its mouth. That mouth is acting like a parachute and dropping its speed all the way down. And now it's over on its belly as it scoops through that krill, and it will speed up it sort of digesting here, but now it's just pushing all that water out of its mouth. The blue whales can double their weight with the amount of water that they intake. Their pleats, their bellies basically extend from their chin all the way down to their belly button. So that whale is full of krill, and we'll see now. So it just finished a lunge, and it's going to do one more lunge. It's tilting up, it's looking at this silhouette of krill. Doing a couple big kicks there. Rolling over through the krill. So this is, if we're at the surface on a boat, we see the whale take a breath, it dives down, it's gone for 8 minutes, it comes back to the surface. What was it doing? Well, now we can have data on what it was doing. And at the same time as all this, we can be collecting the blow sample right now while it's at the surface. We can do photogrammetry and measure the size of the whale with the drone. And then we can start, really putting together this jigsaw puzzle. we have the tag data, we have the blow samples, we have the photogrammetry, maybe we can collect poop from the whale, and that's when the really cool science starts to happen, when we can piece it all together.
Chris,
Yeah.
there's a variable there called jerk.
Yeah, jerk. It's like an acceleration of acceleration. Yeah, it's like literally how jerky is it.
How do you attach the suction?
We'll get there. So how they are traditionally attached, for pretty much all of the years that tags have been around, is the main method is what's known as pole tagging. It's literally using a pole to slap it on the back of a whale. It's difficult. It's functional, and they've been doing it for 25 years. But whales don't like to be approached with small boats. Sometimes whales will approach you with small boats, in which case pole tagging works great. But it's difficult and it's stressful for the whale and the researcher. And as you can see here, this whale was telling them what it thought about it. Sometimes it works great and looks really pretty. So here's a Ocean Institute regular or freelander in Massachusetts. Come on. Perfect. Sometimes it works great, and I just like this is a really pretty one that we filmed last year, and Ari makes it look easy. So he's on the bow of the boat with the tag there, reaching out to the end of the pole, slapping it on. That sprinkles the whale. But what we can see here actually is, so that's them slamming the boat into reverse, putting all that noise in the water. Sprinkles is gone. This was originally a group of 3 that was feeding together, so they're cooperating, doing this bottom feeding behavior, but we've sort of disrupted it. So there's Sprinkles now coming up with the tag on, but out of sync from her 2 companions that she was feeding with. So now that tag is collecting all this data on what does Sprinkle do after you've tagged her with the pole, which is not what the scientists want. So we'll maybe wait half an hour to an hour potentially, and just sort of ignore all of that data until we're certain that Sprinkles is back to their normal behavior, cooperating with the other whales. And ideally, for this particular project, what they would want to do is tag all 3 whales in the group, and then they can correlate all that tag data, and they do these really amazing studies on how these whales are cooperating and feeding together. They have this very unique feeding behavior that they only do, as far as anyone has seen, in this location in Stillwagon Bank. But yeah, so that's pole tagging, and obviously it's not the best. A lot of people have thought, okay, but there needs to be an innovation to this. There needs to be a way we can get tags on without having to do close approaches to whales. The obvious maybe solution, or what everyone had been thinking about but no one had done, is can we use drones to deploy these tags? So we had a couple people approach us and say, we think you guys can do this, and we said, we'll sure give it a shot, and we got to work 3D printing and developing different methods and tools and ideas for how can we use a drone to deploy these tags on the whales. We went with the idea of let gravity do most of the work, drop these tags. These tags actually have incredible suction cups. They've had 20 years of perfecting the suction cup for these tags. And we had a lot of fun with ballistic gel, which you might be familiar with from Mythbusters. It's meant to be a human flesh surrogate, but it actually works really well as a whale blubber surrogate. And we created our own surrogate whales. So we stacked a bunch of ballistic gel blocks together, pushed them on carts and towed them on paddle boards, and tried to drop on moving targets. So when we're dropping these tags, the challenge now is how do you get them to drop straight? So we did a lot of static drops, in the office, standing on a desk, throwing a tag on the ground. whales aren't flat either, so sometimes they're going to land on angled surfaces and do these stick. How do they stick? How do they fall through the air? We can see that one tumbling out of control, but still able to stick. I think this is a compilation here. There might be a couple more. Also, whales aren't dry, so we did some with water on the gel. And does it slip? Does it slide? Does it stick? How sharp of an angle can we do?
Wow.
Also, well, I'll mention this again, but these, we are not developing any tags, so we're using off-the-shelf tags because we don't want to make something that, that everyone has to use this very specifically designed thing. People already have these tags and are already getting used all over the world for different research projects. We're just developing a part in between to attach it to a drone. And that means you can, if you want a pull tag, great. If you have the drone equipment, you just snap it on and go drone tag. So that's us dropping through some water and it's still sticking. So it also looked like it would work. We had some ideas, we knew we could drop it and stick it. The challenge was getting it to fall vertical and land suction cups down onto the whale. This is just sort of a full video in practice of what we've tried to simulate as best we can of what it would be like over a whale. So we're looking straight down with the drone so that the center of the screen is our target, basically. And so that's some early prototype of dropping. And the thing that pops up obviously floats, and we can just go back and pick it up and reuse it. So we're not leaving anything in the water. So these are the two most commonly used types of tags. What's known as a D tag, which is the smaller one on the left, and a CATS tag, which is a camera tag. The D tags are really good acoustic tags, so people will use those for anything that they want to record acoustics on. The CATS tags also record acoustics, but not as well because they're bigger and there's more noise when it's flowing through the water. But what's special about that is it has a camera. So that gives it more size, but the cameras are always really interesting. Yeah.
How much is a drone and how much is a tag?
Good question. These tags you can't buy. You get them collaborate with the University of Michigan, and they'll lease them to you for a lot. The number, I don't know if I'll get in trouble for saying this, but the number is $4,000 for one tag. And you share data with them, so everyone collaborates on a publication. The CAT tags you can actually buy, those are more sort of off the shelf. They run about $10,000. And then there's a couple extra bits you gotta get for it, like the GPS and stuff to track it. So, yeah, they're not cheap. But the data on them is arguably priceless. I mean, there's some things that you can't get without them. So they're really invaluable tools for some of the most important research projects. So this is actually our final design for the D tag. We went with a lawn dart design is what we call it, but the method for stabilizing the tag is an aerodynamic one. So if we drop it from high enough, it'll get enough speed for the fins to take effect and ride it and let it drop vertically onto the whale. And this is all 3D printed from a flexible sort of rubbery material. And when it impacts, the fins will pop off. The suction cups are strong enough to hold the tag on. And it floats in the water. We pick up the fins, and then we're ready to deploy the tag. On the CATS tags, because they're larger, heavier, the fins don't really have enough oomph to correct them. So the only thing we do to modify the CATS tag is we glue this little, call it a topper, but it's a little 3D printed plastic piece that glues on top, and that just facilitates us being able to attach it to the drone. And since we have nothing to correct the fall of these tags, we fly pretty low to the whale, low enough that you definitely need a permit to do it, and just try to fly really smooth and release the tag at the perfect time so that it falls flat and doesn't have enough height and time to fall upside down or anything. I'll show some examples. You guys will get a better idea of how it all works. Does anyone have any questions about it?
What is a weigh, and then, I'm sure you read this, but does the whale respond to its
Yeah. Yes and no. But these tags weigh 300 pounds. I don't know what that is. We do a lot of metric. Less than a pound. With the whole, yeah, these are really lightweight. With the whole assembly and the fins and everything, it's about 1.5 pounds. And that's what these tags weigh. They're closer to 2 pounds. We actually, when you're getting a permit to tag whales, the permitting office asks you what payload you're attaching to the whale, what percentage of the whale it is, because people might want to attach, larger tags. But it's funny because this is like 0.000000001% of the weight of the whale. But you got to put it in the permit. They want to know. They want a number. So I won't go too into this, but if you want to look more at the tech and the radios and how we're making it all work, we did publish a paper last year on this. If you just Google RSOS, Royal Society of Open Science 221376, you can find the paper, or search the name, search drone tag whales publication, it'll come up. But we designed everything to be single operator, so originally in testing I was flying and someone else was dropping, but we're talking about like such limited time to the whales at the surface, it's breathing, there's waves, you've got a small target, and so any lag time between me saying drop it and someone else dropping just made it more difficult. There was also no built-in way to release stuff on the drone with built-in switches and stuff on the drone. We're using DJI drones also, which are some of the most popular drones on the market. It's a DJI M210 for anyone that knows drones. It's a larger drone, but it's waterproof. It's really easy to fly off the boats, and it can carry plenty of payload, so we can carry these tags. So everything is single operator. So I have a switch to release the drone, or release the tag, but the actual radio controlling the release is a separate radio. It's a whole thing. You can read it in the paper or ask me questions afterwards about it. But again, so these are the final designs that we went with. The thin blonde dart design for the smaller D tags, and just the topper on top for the cast tags. So now we finally are at the point where, okay, we've done a feasibility study, we have a design we think will work, but we have to actually go test it on real whales. And so we went to our favorite place, which is Loretto. We've been doing snowplot studies there for 7 years now. All these green dots here are previous drone flights we've done over blue whales in the Loretto Bay National Park. We work with Dr. Jorge Raban down there, and it's a fantastic place to go work, and also the largest target on the planet to try to hit with a tag. And spoiler alert, it went great. So these are some successful tag deployments onto blue whales, and this is demonstrating the difference between the D tag and the fin and the CATS tag that I was trying to explain before. We have our release system just underneath the drone. Again, everything is 3D printed and designed to just bracket onto the drone. So if anyone else has an M210, they can print out our system on their own printer and just bolt it onto their drone. All off-the-shelf components or the 3D print files are openly available to anyone. So with the D-tag, we have to fly pretty high up. You can tell by how much of the whale we can see how much higher we are, because the fins need enough speed, which is height and gravity, to take effect to correct the orientation of the tag. The CATS tag, on the other hand, we want the opposite. We want to fly it low and close and drop the tag. We're just dropping the whole tag as is. There's nothing popping off it at the end, nothing to stabilize it though. So we want to make sure that we drop it close enough that it won't fall out of orientation before it hits the whale. And you can see it, sort of sliding a little bit, but once it gets a grip, it's on there, and then it's along for the ride until they pop off.
Why is the 3D printed parts multi-piece?
Good question. There were sort of three parts because it was always like an iterative process. So we had a tag holder, which is the bottom part, holding the tag, but we didn't know like what size fin we want or how tall or how wide it's going to be. So we could modify just that piece without having to modify the tag holder that we knew was the right size and worked already. Same with there's a, there's like a blue piece on top of the fins that attaches to the root system. We really fine-tuned how well that fit and the shape of it and sort of how it all fits together. So we could basically make lots of iterations of that without having to print, the whole fin. We could do things really quickly. So that's why it's sort of like a three-part thing.
What's the success rate?
I'll get there.
Okay.
Yeah. You first. Sorry.
How are you flying over the whale, and what kind of knowledge do you know about maybe harassing the whale?
Yeah. Good question. I have some numbers in a couple slides, so I can do more about that then.
Do you get a sense for whether the whale feels it or not?
We do see some reactions sometimes when it lands on the whale. We have the tag data, so we can literally see what the whale does afterwards. And we've done some work side by side with pull tagging, and pretty much unanimously everyone prefers this because they seem to get back to their normal behavior much quicker than approach it with a boat. Yeah.
But have you done like any drops on land away from the whales just to measure the impact?
Yeah. Well, again, we have all the accelerometry on the tag, so we can get that impact from the actual tag data itself. And we can compare it with the pull tagging data. We're actually impacting the whale less than the poles taggers will, because they have a 40-foot pole that they're really swinging down on it.
And then for the speed that you're flying right there while the whale's moving, what speed are you typically moving at?
It's usually a couple miles an hour. It depends on the behavior of the whale. They could not be moving, they could just sort of be floating there, or they could be going 4 or 5 miles an hour.
Well, I only asked because I was looking at how short the fins are.
Yeah.
And you're talking about being high enough for the airflow to correct the drop.
Yeah.
And so I'm thinking naturally longer fins, more,
Yeah.
air to surface, easier to correct, but maybe the speed you're moving at is why you couldn't have a longer fin.
Yeah. There's also it just being like cumbersome on a boat, and someone has to like hold the drone to install it. You can't just be sitting on the deck, and so there's a lot of different things that you sort of learn in the field on when you're actually using it in the field versus designing it, engineering style, where it's like, this is the most efficient way to do it, but it might not be the most, it might just be pain in the
Might
ass
not be
in
the
the
most
field.
practical.
Yeah, exactly. So this was like, all middle ground, but it certainly wasn't a perfect design, but it works, and we will see. We didn't have enough time to iterate on it because we were just out there using it. So I'll answer some of these questions in some next slides here. So another thing that we learned that we couldn't really simulate is how the whale itself is affecting the fall into that. So obviously the whales are there and at the surface breathe, and when they breathe, a blue whale, especially in particular, can exhale at hundreds of miles an hour. And when we're approaching the whale to drop the tags, we're often in that exhalation, much like we would be with stop putt, just more unintentionally in this case. But we do actually very often collect flow samples and deploy tags at the same time. So here we'll see when the whale blows, it's really shaking and rattling up the drone, flying through that exhalation and all that turbulence. And we don't want to drop the tag, especially the cat's tags with nothing to stabilize them, in the middle of that, because the drone's shaking around and it's just going to release and flip upside down and have a very low probability of actually attaching to the whale. So the technique that we've developed is, and works well for timing also, when the back is going to be exposed, and when you're going to have the best chance of landing on a good dry spot on the whale, is the whale's going to come up, it's going to breathe, the drone's going to shake around a little bit, then it'll stabilize, and right at that moment is when we want to drop. Oops. Another thing that we learned in the field, which we sort of knew because we were dropping on really small targets when we were testing the paddleboard to do a blue whale, it's a pretty big difference. But we were able to, this is a rare occasion, we wouldn't normally do this, but on the first field test, we were trying to just deploy as many tags as we could to really test out the system. We actually double tagged this animal. We first put the camera tag on, and then we said, okay, can we drop the D tag in front of the camera tag to see how our release system will pop off, how the tag attaches, and also just get a really cool shot. So on the left here, you see the drone perspective, so the tag falling away from the drone, and where it is in relation to the camera tag that's already on. And on the right here is the view from the camera tag, where you can see the tag hitting the whale, the fin bouncing off, and floating by for us to pick up.
How long do they stay on there?
So at most it's usually about 30 hours. There's been long exceptions. Usually they're not on for more than a day. But this is actually a good segue into this. We need to recover the tags again, right? So you don't want to put it on a whale that is deciding to, swim to Oregon today, because you might not get it back. So a lot of times we have to think logistically about okay, what's the time of day, what's the weather tomorrow, what's the behavior of this animal, what's it doing, and we'll either program the tags, or there's different ways to set them to release from the whales. But we want to think foremost about we want this tag back, because obviously they're really expensive, they have really valuable data. So it's better to have 2 hours than 24 hours if you're sure you're going to get it back. So the way that we get them back is they'll have beacons on them, both GPS but also VHF is really how you track it down. What that is just a radio beep. So every second it's sending out a high-pitched beep on a specific radio frequency. You tune to that channel, and we use a directional antenna. And when you point at in different directions, the beep will either be loud or quiet. And based on how loud it is the direction you want to go to find it. And you just keep doing that and turning down your sensitivity little by little until you literally find a needle in a haystack. I don't even know if you can see the tag there, but the small ones especially are very small. The engineers that build them like to be engineers, so they originally had them painted all black because it had the best UV protection. And we're like, great, we don't need that, make it bright orange, please. And just a fun picture on the right there, sometimes they end up in places you wouldn't expect a whale tag to end up. This was actually in Puget Sound with gray whales, and the tag washed up on the beach overnight. And someone was on their morning walk and saw this thing on the ground and picked it up and brought it up to the jacuzzi. And this is one of our researchers on their trek back down from this guy's house to recover the tag. So using these antennas, someone on the boat was pointing around and we could hear it, but we couldn't see it. And he's like, I think it's in that guy's house. So here's some of the numbers you were asking about. So this is just from our first expedition to Loretto. We deployed, I think it's on the next slide, over 20 tags, both cats and D tags, on blue whales and fin whales. And our average distance from when we launched the drone to drop the tag on the whale was almost half a kilometer. So as far as harassing the animal with the boat, we've pretty much completely removed that from the equation. The boat is here, the whale is there. There's no interference from the vessel on the animal. They do respond to drones, and funny enough, blue whales seem to be especially skittish compared to other species, which is a weird like elephant and mouse kind of deal, but obviously not enough to prevent us from being able to get the tags on. And once the tags are on, then we're done with that whale. And so again, to that point, the average time from when we launch the drone to tag on the animal is 2 minutes and 45 seconds. So we're not spending a lot of time with that animal. We just need, one good surfacing to get over it and get in position and then drop the tag. And when we're done with that animal, we don't need to follow it all day long and wait for the perfect opportunity to get the tag on. This sort of max here, the max distance we were able to put tag on was 1,000 meters, so a kilometer away. And the shortest time in this case was 43 seconds from when we launched the tag to launch the drone to tag the whale. And then to success rates. On this first trip, so never done this before, I've never successfully tagged a whale with a drone before. We had almost 60%, so basically 2 out of every 3 drops that we did, we stuck it on the whale. Just a nice good whale tag there.
Why the difference between the two? Something about the
Oh, yeah. So this is again to the point of the cat's tags and the D tags. With the D tags, we're flying higher, like here, and when you're flying higher, you're smaller target. So what these numbers are showing is D tag flying higher, hit the whale less. So sometimes we miss and it lands in the water, but the fins were really good at getting it to fall straight. So if we do hit the whale, it sticks most of the time. So 16 out of 18 times that we hit the whale, the tag stuck. On the cat's tags, on the other hand, we can hit the whale almost all the time because we're flying 6 feet above it. But it only sticks, 5 times out of 8 times. It's gotten better. There's new systems where it's, I've done trips recently where it's just one done. I'm getting tags on like nothing. So this was great, and it's improved since then, which is amazing. So that was the first proof of it. Now we know it works, and now we're getting lots of calls from people all over the place saying, we want that on our projects. And so we had to think about, okay, what are the best applications for this new tag deployment method? The sort of main areas that we think this method is most applicable is obviously hard to work with species. So there's some species of whale that are just really hard to get near with boats, or very responsive to boats. Endangered species, so species, obviously with endangered species, you don't want to further stress them or harass them or do anything that might further their decline. And then there's also been some interesting projects that people have thought about doing, but it hasn't been possible with sort of approaches to deploy tags. Projects where you're doing like playback studies to whales, where you want to see if I play this noise to them, what is their behavioral response? But if that noise is like a ship noise and you're doing all the ship noise just to get the tag on, it doesn't make sense. So we've had some projects recently where we're using the drones to deploy the tags and then doing playbacks from vessels. Sort of projects that wouldn't have been possible before now. So the first call that we got was to go do sei whales in Massachusetts. If you know anything about sei whales, you know that no one knows anything about sei whales. They're a very interesting whale species. They're an endemic species. There's a group of them that feed off of Massachusetts, 10 miles away from Boston, and no one has really been studying them because they're just too difficult to follow and keep track of and work with. In the world, I think before this, I think 2 of them had been tagged, and in North America, no one had ever tagged one. And a lot of the reason why is because they're like giant sardines. So that you can see them here, this is sped up, but there's, I don't know, 6 of them doing their feeding behavior. They're always just beneath the surface. They side lunge, so their backs don't come out of the water, but they just take like a gulp near the surface, and they're just going around random directions. Here's a close-up of their lunge feeding behavior. So we worked on a project with NOAA, and they had a team of 20 people. They had 3 boats, 2 weeks on the water. Their goal was to get 2 tags on, double the amount of tag data on sei whales in the world. We got 10 tags on in 3 days.
Are they also eating krill?
Yeah, those are copepods, similar to right whales. So yeah, they're like zooplankton. So this is a run through. I'll talk over this while it plays. So this is what I see when I'm flying a drone, with some extra telemetry down here, so we can sort of see what inputs I'm giving it. We're going to try to deploy the CATS tag, so the camera tag. That's the view of the camera on the top right there. And we have our target whale here. So this will really demonstrate why sei whales are so difficult, and everyone was like, screw sei whales, I'm going to study something else. So we're working down to like our target altitude. We're keeping a little bit of extra height so that we're try not to bother this whale too much. If you know drones, this is for the drone people. I'm flying in a mode called ADI mode. Normally drones will like hold position, so you let go of the sticks and the drone will stop and sit where it is. In ADI mode, when you let go of the sticks, the drone keeps going like ice. It makes it, in my opinion, much easier to follow a moving target, but also what it means is you can see like the pitch and roll of the drone here, how much movement the drone has. When I let go of the sticks, perfectly calm day like this is really nice because the drone will go perfectly flat and just keep gliding along, matching the speed of the whale. And I know I can drop back at that point, and it won't be at any weird angle when it's falling. I know it'll drop flat. Or as flat as I can control it. So the whale hasn't come up for breath yet. From a boat, you wouldn't even know it's there. But from the drone, we can see it through the water. We have a little map here of what it's doing. It's actually just doing one really big circle. And we're just sticking above it and keeping track of it, waiting for when it's going to take that breath. What we're looking for as the pilot is usually an indicator is when pectoral fins go straight out to the side. We can see, one's out, but that means it's kind of rolling and turning. When it gets both out, you'll see it. It'll be apparent, and then you're like, okay, how's my chance? It's going to come to the surface. It's teasing us, but it's not quite there. And again, when my camera is tilted strict down, normally I would have like an X on my screen, so the center of the X is sort of my target. And I'm trying to keep its pectoral fins in frame. I don't want to go too far forward because I don't want to fly over the head. But I don't want to go too far back because then you sort of lose a sense of where you are on the whale. So there it goes. It's got both pecs out. It's coming shallow now. I'm dropping to the height I want to be, waiting for the blow, dropping the tag. Yeah, and off she goes. Back to the other group. Sails, I think probably about 50 feet. They're very sleek and skinny and fast, and they're really cool animals. From this first study, Dan Cusano published a paper, one of the researchers on the group. They detected some say whale calls, which is really cool, but there's lots of passive acoustic work that goes on in this area because it's the shipping lane coming into Boston. And they do monitoring for right whales and humpback whales and different species. So it's important really to have this data and identify these new calls because now they can update the stations there to be able to say the say whale. Whereas before it might have just been where it is. You don't know what the sound is. Any questions? Yeah.
Chris, what's the rough time between breaths for whales? Or I guess they vary, but roughly what's the time difference?
The time difference, sorry.
Between breaching and breathing?
On say whales, we had flights where I was flying for 12 minutes just following the whale before it came into the breath. Generally, I'd say the average, almost all baleen whales, so these are baleen whales, they don't have teeth, they have baleen, is usually they'll be sort of down for 8 to 12 minutes and then up for 2 minutes to take a couple breaths and then back down again for 8 to 12 minutes. It depends on if they're feeding or if they're traveling or if they're just kind of rolling around.
You have to get FAA clearance every time you launch?
Not every time we launch. We have Part 107, like commercial pilot, and then we have National Marine Fisheries permits to fly drones over whales. Now there's all these new remote ID rules and all that stuff. But,
You say you don't want to go forward towards their head because you don't want to drop the tag, but can they see a shadow or hear or?
Yeah, every now and then a whale will be kind of curious, turn, look up, or and yeah, I mean we've noticed it with Snapbot too. If you have a sunny day, sometimes you're at the right angle where the shadow is kind of over the head of the animal. We generally what we do, and you'll see it in some more videos here. We'll approach from behind always, and so we'll sort of sneak our way up over the tail. We don't want to go like head on with the whale or come in from the side where you might have a better chance of seeing us.
But they wouldn't have predators that come from above, so.
Yeah, I wouldn't think.
The curiosity.
Yeah, and it's kind of a weird thing. I mean, they're probably used to wind and waves and birds, and yeah, there's been some new studies into different drones. I mean, this is a fairly large drone. We're trying to shrink it down, but this is like what we're just the current tool right now. But ideally, we'd use a smaller drone and make less because it have less damage from the water. This is just one more say whale clip that we like to show or put the tag on, and then 4 seconds later is just continuing to feed, so seemingly not bothered. So then, straight from there, we get into the next project, which is gray whales in Puget Sound, which is where that tag in the forest was. And this was an interesting project where this is a funny group of gray whales, 20 or so whales that split off from the main migration route of the gray whales that are just swimming by us now. And they go way deep into Puget Sound and feed on ghost shrimp that burrow in the sand at high tides. And it's the speedy behavior that only these gray whales do. None of the other gray whales do it. Only this group that comes in here. And they've been photo IDing them, so it's the same whales that come in here. And so recently they wanted to tag these animals and see how they're cooperating, how they're communicating, what's their feeding behavior like. How much weight are they putting on while they're here? What's so beneficial about this location to them that they're keeping it secret from all these other whales or whatever they're doing. And they often feed in groups, so ideally, you tag all the animals in the group and see how they're cooperating. But on the first study they did, I think 2015 or 16, when they tagged these animals. They were pull tagging from the boat, and they would go and they'd get one tag on, great, they'd try to get another tag on, and by then the group would be split up, and they wouldn't get back together, and they wouldn't get that data that they wanted. You could still get tag data, they're still able to get tags on the whales, but not this group behavior that they wanted. So we had something that they thought would help. We went out there, I flew for them, and we deployed a bunch of tags. And here we have a group of free whales, and there's actually a tag already on that whale, and there's a tag on the second whale. We're trying to go for 3 for 3 here. And again, so this is a CATS tag. We're flying at this low altitude. We don't have anything to correct the orientation of the tag. Whale seemingly not too bothered by the drone. Still together with this group, comes to the surface there, tag, stuck on, and off she goes. So 1 whale, 2 whale, 3 whale. You see the orange blip on that one, the pink blip on that one. So they're all still together, and they went out to collect fossil data. Yeah.
Can you possibly tell us where? Can you tell us?
We went out of Everett Bay. Yeah. I don't know the island that we were working around at the time. Yeah. That would be it. I'll be back there in a couple weeks. It worked so great, they want to do it again. We'll do a couple more projects with them. So on to the next spot. Oh, yeah. Yeah, no, it didn't seem to make any effect. I mean, whale was kind of crusty, but it would stick just fine. We had great durations on the tags. There wasn't anything that made it seem like it was an issue. Yeah.
Because we found down to these, do you have any issues with the tags staying on gray whales for a certain length of time?
Because they're like scraping them off, or that happens. They get scraped off, but we've also had tags that have been like whales bump into each other and reset the tag, and they actually had a tag, not with me, but they had a tag that was on for like 72 hours because it just kept getting stuck on the whale. You get both. Any questions? So we're going to be running through like a bunch of projects now. So we're just going from new application to new application. All these really cool projects that drone-based tagging is really changing the game. So the next one is North Atlantic right whales, the most endangered species on the East Coast, whale species. Less than 350 of them left. They're getting entangled in fishing gear. They're getting hit by ships, out in the New York shipping lane, which is very unfortunate for them. But again, with endangered species, there's this balance of kind of you want to collect all this data you can to help protect them, but you want to be cautious with how you do that because you don't want to be adding any further stressors into these animals' lives. So tag data is really important for right whales because you want to see how they're using their environment, how much time they're spending at the surface and vulnerable to ship strike, or where they're feeding on the bottom and how vulnerable that makes them to different types of entanglement and different gear. So hopefully you're getting the point by now. It works great with the tag whales. This will be with the D tag and the fins. See it almost falling sideways there, but correcting just before it hits. And off she goes. This is also this view here, if anyone's confused about that. We're using a 360 camera that is sticking out in front of the drone, and it stitches itself out. You can turn it around and look back at the drone and get these really amazing shots. Another thing that we realized off this right whale trip is we were 100 miles offshore working off a large research vessel, and it doesn't look like terrible conditions, but those are actually pretty big swells and pretty rough seas to be on a little boat, which is what we planned on doing. So there's little zodiacs on the back of this that the crane would pick up and deploy in the water, and then our tag team would get on that boat and we'd go work with whales off the little boat. It was too rough to launch the little boat. Had a team of 20 on the boat, NOAA funded, spending lots and lots of money out there at sea for a month, 100 miles offshore, and we're like, well, it's kind of wavy, so we can't do any work. All we can do is take photo ID of the whales, and that's like the extent of it. But we're like, hey, we can fly from the big boat, we can launch the drone, it's perfect drone weather, it's just a bunch of waves. So why don't we fly from the big boat? Because the big boat can maneuver well enough to pick up that fin afterwards. We can still deploy tags. And we did, and it worked great. We got 7 tags on, and amazing boat captains that were able to keep track of those little fins and pick them up afterwards, so we didn't leave any fins behind. And that really opened up sort of a whole new potential for the types of projects that then we could get involved with, where we can fly out the large boats without needing to have a small boat to operate. We could do these kind of offshore expeditions with whales in kind of any environment. So that led us straight into this next project, which is fin whales south of Martha's Vineyard, actually in a wind farm construction area. So this was the first sort of large-scale project to go and tag a bunch of fin whales. We chose fin whales because they were the endangered species in the area. Well, I'll just play the videos here. So here's a wind farm construction boat. They're carrying one of the pilings. And this is the boat we were working off of, a beautiful sailboat. There's a fin whale getting tagged. Fin whales also, this is sort of a double whammy, but fin whales are a notoriously difficult species to work with. They're extremely fast. They're extremely hard to approach. They don't want to be approached, and they'll just go down and take off and pop up a mile away, and you'll never see it again. We tagged 20 fin whales in a little over a week. I think we had like 10 days on the water, which is a crazy number. Part of that is because blue fin whales are actually really slippery animals, so we put a tag on and it would slide off like a couple hours later. But we just pick it up and just put it on again. So we're getting lots of tags on and operating all off of this and all sorts of different weather conditions. Question? So after that fin whale project, finally had the winter to kind of sit down back in the office and try to come up with some new ideas, new iterations on the design. We have the next project was an interesting one where we were able to use the drone that we were using most of the time. We stepped it down to this drone, which is an Inspire 2, also DJI, which is a smaller drone. It can't carry as much payload, but still able to do the tags that we were dropping. And then we wanted to think of a better way to stabilize these smaller tags rather than the fins. The fins worked, but having to get that sort of minimum height to get them to get enough speed to correct the orientation and all that was a little bit of a challenge. It's just like one extra thing to think about. So we came up with a new way along with one of my interns. We, rather than aerodynamically stabilize, we're now sort of physically stabilizing it. What this is, we call it a gyro. It's like a flywheel. It's a spinning weighted wheel. And there's this really fun physical property where we have a spinning thing in space and you drop it in free fall. It's kind of locked into its position. It's kind of how they orient satellites and stuff. But we have, an extra little motor on the drone now that will spin this wheel, and the tag is attached underneath. That rubber part is what's holding the tag. This is a new type of tag here called an AccuSon tag, which we're now deploying. So we have 3 types of tag in our repertoire. But this works incredibly well to stabilize the tag at any altitude. So it makes it a little bit easier. That's sort of one thing out of the equation. That when we're approaching whales, we're not so worried about what our height is at. Just where we can be, wherever we are when we get there, we can drop it and it'll fall like a brick.
gyro speed?
Takes like 2 seconds. I don't know. It goes pretty quickly. And it spins at like 2,000 RPM. And it weighs pretty much exactly the same as the whole lawn guard system. Part of the other reason for this was to shrink it down to smaller drones. So we flown this off of even smaller drones. But that'll come this year. We'll have some pretty small drones with the idea that we can tag smaller species or some of these more safe species that are more responsive to the drone. So this is, I'll play this and then I'll explain as well. Listen closely for the whale song at the end of this. These are Arabian sea humpback whales. They have this weird, they call it like a ghost horn. It's a very unique sound that is part of this humpback whale population song that isn't heard anywhere else in the world. Yeah, that was Zadra. So, just some fun facts on the Arabian sea humpback whales. They're the only resident population of humpback whales in the world. So they don't migrate. They're in the Arabian Sea year round, and it's been that way for sort of 60,000 years. At some point, split from the southern Indian Ocean humpback whales, and they're just their own little self-sustainable group. They find food and they breed all in the same area, but they're extremely endangered. There's like estimated less than 100 of them left. So they had never been drone tagged before. We're in a really remote location in Oman. We're launching boats off the beach and hoping to see one of these whales. I think we saw in the 2 weeks we were there, we saw 8 of them, and we tagged every single one that we wanted to work with. But they were extremely difficult to approach with boats. There was other work that they wanted to do with these animals. They wanted to satellite tag them, which are implantable tags, which require them approaching with a boat. They got one of those on. The last day on the water, we got 7 tags on every time we wanted to work with a whale. So it was a really good demonstration of the sort of the drone methodology on species that was pretty much unworkable otherwise, and really cool data on a very special species. Yeah.
You mentioned NOAA funded one of your expeditions. Is that where you get most of your funding for your research and your projects?
Yeah, they're not actually funding us directly. We're getting brought onto the projects as like contractors. So it's NOAA themselves usually running an expedition, and then picking people to be on the team to go out and do the field work. A lot of this was funded by a grant from OceanX. They funded sort of the original development of the system, and then we, paid per working for NOAA, we get paid by them to work on the project. So doing the field work is actually what's paying to continue development, and then we get on further grants from OceanX and stuff.
Chris, what's the lifespan of the whales?
The whales? Really good question. I think I would say like 50 to 80 years, depends on the species. Some whales live really long. There's probably some whales out there that live through, like the peak of commercial whaling and are still out there surviving. Interesting to think about. This is.
Are you tagging the babies too?
We haven't tagged any calves yet. We've tried once, but most of the time there hasn't really been like a research question or project that we've been on yet that would require that. We tend to try to leave them alone as much as possible. This is just a video on that new gyro system I was talking about in action. So you'll see it dropping flat with the new type of tag, the Acuson, and it just popping off the same way that the fins would. That was with that third type of tag, and this is with those the D tags. But normally with the fins, it's flopping all over the place. It can land at weird angles and stuff. This is flat the whole time. It also allows us to deploy these tags from lower and do the thing I mentioned briefly before, but we can collect a blow sample and deploy the tag at the same time, which is great to sort of two birds, one stone, not have to do further flights of the animal. And getting close to the end here, but so another thing we've been looking into on sort of what are novel ways to use drones in marine mammal research, and what are other research requirements that require close board approaches, all these things that make pole tagging difficult. They're pretty much all the same things that they have to deal with in disentanglement responses for whales that get entangled in fishing gear. So we've been exploring a little bit. I won't go too deep into this, but we've been exploring using drones to carry some of the same disentanglement tools that they use, cutting grapples, hooks for grabbing lines, and trying to free whales from entanglements. Sort of the same, we're sort of in the early feasibility study stage of that, like we were with the tags, where we're doing stuff with dummy whales and things. So just some examples of what we've been doing. We're towing grapples. We have some release systems that we've designed, so when we hook it on with a line, we can tug with the drone, it'll release after a certain amount of tension. Some interesting stuff that we've been working with some disentanglement in Hawaii and seeing some really cool results. So hopefully, in the next year or so, there'll be some practical applications for this that can really help in some certain situations. But one thing that they do in disentanglement responses is you want to get an assessment of the animal. So we had the opportunity about a month ago to actually deploy the camera tag on an entangled animal in Hawaii and get sort of an up-close view of not only what that entanglement looks like on the animal, but how it's sort of living its life, its daily life then with that entanglement. How much energy is it causing it to use extra compared to if it didn't have an entanglement? Is it affecting its behavior at all? Is it not necessarily feeding here, but is it affecting how it's interacting with other whales, or other whales interacting with it? You guys know how this goes already, but there's one little twist. There you see this entanglement actually through the mouth of the animal. Which this was a unique opportunity because at this point it wasn't yet a life-threatening entanglement for the whale. So they were gracious enough to let us, further harass this animal. But what we did see from the tag data is we're not affecting its behavior. It's not been taken off away from the response vessel. They were still able to make an approach on this animal and attempt to free it. So it's doing all this stuff with the drone, keeping the boat away, saving that. Your best approach in a situation like this, if you want to get up close to the animal, is your first approach. So as much work as we can do with the drone, leaving the boat out of the equation. When you need the boat to come into the equation, that first chance is your best chance. So this is just sort of the latest area that we're exploring with drones, and excited to see where it goes. And that brings me to,
in watching the time frame and kind of whales' behavior, is there evidence sense that you're communicating stress to others, or that others are sensing and responding?
That's a great question. I have the answer to that. I don't know how much research has been done on that. Huh? Oh, I'm sorry. Yeah, so the question was, when looking at entangled animals, is there any evidence or have we seen them communicating stress to other whales or other whales being stressed because that whale is stressed? I don't have the answer to that. It's a really interesting question. There's not a lot of like tag data on entangled animals. There is some. I haven't looked into the research, but yeah, that'd be an interesting thing to look into. Yeah.
What's the total time frame for what you've shown us tonight? Like the first time?
Yeah, good question. So the development of it was fall 2021. The first time we tagged it was February 2022. So it's been 2 years. I stopped counting. It's over 130 whales that I've tagged in the last 2 years using a drone. 6 different species. Hoping to add 1 more new species this year, Rice's whale. We have a project with them. It's really exciting in the Gulf of Mexico. Yeah, it's been nonstop. Yeah.
Have you gone up to the Salmon Islands and studied the orcas?
No, we just saw orca in Mexico while we were there, which was really exciting. But I won't say too much about orca people in the Northwest, but they're a special breed of whale researchers.
What's your feeling about the state of the whale health after all this work?
Good question. So the question is, what's my feeling on the state of whale health after all this work? I think my sort of, hopeful answer for that is whales will be great if we give them a chance to be great. Whales are really good at surviving and just keeping on going. They're very adaptable, especially whales like humpback whales and gray whales. It's just like we're not letting up on anything we're doing to make it more difficult for them. So some populations live in areas and have special feeding behaviors and skill sets that make them, they're doing fine. Like humpbacks on the Pacific, they're doing just great, they're gonna be okay. Other whales, like right whales, they need help. So it really depends on the situation, but I think if we, do our best to help them, things will be better, they'll be okay.
So what can we do to help?
This is my mom. What can we do to help? A lot of people don't realize there's krill oil in lots of products, like fish oil supplements, even things that aren't directly fish oil supplements, but might be like omega improved or whatever. Krill fisheries are extremely damaging to a lot of different whale populations, and also just sort of the larger ecosystem. So don't buy krill products. There's other things. There's more natural sort of vegan solutions for omega. And also just the little things. I mean, no one person is gonna, change the world, but if everyone is more conscious of what they're doing, that's affecting, the larger ecosystem. When you wash clothes, lots of microplastics can get into the water system, the waterways. See a piece of trash on the beach, you might as well pick it up and leave it there. If everyone was doing, just a little bit more, everything is adding up to making the world a little bit better. Yeah.
Do you know if any other research groups are using your 3D plans and tagging whales on their own?
Yeah, so we're just sort of getting up to speed. A lot of the projects we've been on, like I mentioned with the democratizing science thing, we'll leave all the kit there, minus the drone, sometimes the drone, but we'll leave everything there. We'll work with one of their pilots and train while on in the field with them. So there's a couple different groups now and there's different people. I'm not the only one that's tagged a whale. There's a couple different people now that we've trained that are also doing it. So it's growing. I'm definitely doing the most of it, but yeah. And I imagine, the next year or so it's really going to start to there'll be a lot of groups that want to do this.
Would it be possible to use these tags to study like sperm whale or other whales that can really dive deep?
Yeah, these tags are rated, I have a tag here, if anyone wants to see a tag after, I can pull it up. They're generally rated for like 1,000 or 2,000 meters, depending on the tag. And there are some people that make, hardcore specific sperm whale tags, that we haven't had our hands on yet, but I'm sure we could pull with the drone also.
At the beginning you said whales are really valuable. Wasn't there some number placed on that by that study?
Yeah, it's on the paper.
Yeah.
There's a lot of numbers in that. We're all done. There's numbers like there's an estimated global population of like 1.5 million whales. Pre-commercial whaling, there was 4 or 5 million. So if you imagine even a few percent more whales, that's, I don't know, numbers, 60 million more trees or something. It's like just small percentages more whales towards what they were pre us taking huge amounts of them out of the ocean would have a huge positive impact on global carbon capture. I think the number, and I guess the headlines is one great whale, like a blue whale, is the equivalent of 1,000 trees.
Yeah, not to go down a rabbit hole with this, but the ocean ecosystem in terms of carbon capture is much more efficient than plant-based, because plant-based tends to be kind of an annual sink, where carbon's absorbed, but then when the leaves fall off the trees and things, it's re-released. So whereas the ocean tends to be more permanent, more sustainable, greenhouse gas recapture.
Yeah. So it's just people in here, it's a comment that land-based carbon capture tends to be more sort of seasonal and cyclical, where the trees and stuff are pulling carbon out of the atmosphere, but then the leaves fall off, it gets on the ground, it could be fire, it can throw all the carbon back in the atmosphere. Stuff in the ocean tends to stay in the ocean and happen year-round. And the great thing about the ocean is a whale itself, for example, is one large carbon sink. So we're all carbon-based life forms, and this is a 30-ton more, chunk of carbon. And when that one dies, it sinks to the bottom of the ocean. That carbon is buried and stored there for a long, long time. Hopefully, we don't come digging it up.
What about from your snotbot, the biological samples? Lots of microplastics found in that, or any, or?
Yeah, not so much in the blow, but we have been, so a lot of research now that we have all these different drone-based health metric data collection protocols. What we're doing in Mexico this year, working with Blue Whale people, is we would tag the animal, we collect a blood sample, we do photogrammetry to get its length and width. We get a photo ID so we know who it is, and then the holy grail will be to also collect poop. So we have this sort of like full platter of data on this one individual, so that we can start really trying to dig into the data and make sense of what's in the blood samples. The feces is where you see most of the microplastics. That's what they're injecting, what's coming out. And but what's also great about that is you can use hormones in there and different DNA, microbiology, all this stuff to validate some of the other blood samples. So we did that in Mexico, which is really exciting. So we have this full data set on an animal now that we can dig into. But yeah, microplastics mostly in the poop, and a lot of, I think there was a publication recently that came out on microplastics results from these blue whales.
Well, I'd seen in some of the other mammals where they found microplastics even in the fat tissue of the animals.
Yeah, I mean, if you think about it, a whale is the perfect ocean vacuum.
Right.
It's at the surface, taking huge amounts of water in. It's going to have lots of microplastics. It's sort of a never-present issue these days, unfortunately. Other question about that?
I know Ocean Alliance at one point had a couple other drones in beta testing. Where are those at now? Have you guys been using them?
Yeah, you're talking about like we had earbot, FlearBot, and all these other things, yeah. Yeah, I mean, that's what we do at Ocean Alliance is we sort of come up with lots of ideas and we see what sticks and then we keep going with that. This has been taking up like the bulk of our time. And we're actually a really small team. There's 4 of us full time in the office. So we only have so much capacity, but we do have, a list of ideas that we're ready to start, going down the rabbit hole again if we get funding for doing that. So, yeah.
How do you collect the pieces?
Scoop it up. No, well, we just drive up to it. And a blue whale, for example, it's usually pretty obvious poop. A lot of times we'll actually, when we're flying the drone over doing blow sample or photogrammetry, we'll be like, oh, whale's pooping. And then we'll drive up there. You can smell it a lot of times before you see it. But yeah, we just have a net or like a stainless steel colander and scoop it up. Yeah.
Not the same way you use the mop.
No, you use it.
How big is it?
You get pretty good chunks. Hopefully. Blue whale poop is like bright pink because they're eating krill. So it's kind of fun.
I was thinking about your 4-2 team, like late nights, so who's gonna think of the best scooper?
The best scooper.
Like a
Yeah.
fire, like some sort of like a scraping unit.
Yeah, we could do it. I mean, we have the disentanglement drones. They're already there, so yeah. Normally, it's like you're there with the whale anyway, so it's pretty easy to just like go up on the boat. Yeah. Off like in the big boat or something, having a drone to collect food would be great. Yeah. Any other questions? Yeah.
When you were doing photo ID and getting stock samples, were you able to get like solid enough DNA samples to identify down the individual and match it with the photo?
No, I don't think so. So again, I'm not the biologist, but my understanding is there's not quite enough DNA there to get that specific of like a genome sequencing. There's other new methods. There's this thing called shotgun metabarcoding, which is like new sort of lab analysis methods for getting more different types of DNA extracted from that sample. One thing we can do is just tell male or female, which is actually kind of important and useful because a lot of times you can, like whales will have IDs, but no one will know if they're male or female unless you see it with a calf and then you assume it's female, or it shows you its underparts, and then you can determine whether it's male or female. A lot of times you don't see that, so there's a lot of whales out there that people have been following it for 20 years, but they still don't know if it's male or female. So in the past, it would just be you have to get a biopsy sample, so you have to get up close and shoot it with a crossbow basically and take that physical sample that you can go analyze. Now, actually, the recent development is from the tags that we deploy. When they come off the whale, you can swab the suction cups, and that has enough DNA on it to determine if it's male or female also.
So some whales have teeth, right? I mean, I've down with those. I know that some do, some don't have teeth, right? So are they finding the reason you're finding that some of these whales are getting, teeth infections and things like that?
I haven't seen that. I mean,
Oil infections.
yeah, because we're looking at lung microbiome. So, and whales have some weird anatomy. I don't think their mouths connect to their noses like humans do. So, I don't know. Yeah. Sorry. Yeah, go ahead.
Have you had any opportunities to study the whales in the Pacific Zadra, or any of the garbage patches?
No, we have not been out there. I know there's the Navy does like training every year between Hawaii and Southern California. I don't know if that would technically go through that kind of area, but there's lots of sort of, when the Navy's doing a big project like that, there's a lot of marine mammal researchers involved, doing all sorts of different collection on whales and dolphins and stuff.
Chris, is it your impression that all disentanglement centers and efforts would include if they were drone trained? And if so,
Yes. So the question is if I think disentanglement centers would improve if they were all drone trained. Yeah, I mean, I think on the West Coast, it's very well adopted already, especially for just the assessment portion of it. Because again, like if you're looking at a whale from a boat, that's like the worst way to look at a whale. You want to be, above it or below it and get sort of the full picture. So there's lots of groups that use drones for just getting a picture of what this entanglement looks like. But there's lots of ways that can be expanded and extrapolated. So using drones to help, again, a whale's just beneath the surface. From the boat, you can't see it, but from the drone, you might be able to pick it out, helping guide disentanglement crews towards animals. And then, like, we've been working, trying to actually deploy tools and use the drones to cut lines and stuff and be able to approach the whale without the boat. So it might be more approachable from a drone where you can get a tool on to cut a line to free the whale. I don't see any downside to people getting trained in what they have available with the drones. There's obviously different levels at where they can apply the drones. But a lot of groups, well, not a lot of groups, sometimes, and this is sort of every industry, and people have a method that works, they've gone out, they've done it, they know what they know, if it ain't broke, don't fix it. So people can be reluctant to take on, new tools and stuff. But we have good partners that are working with us, and we'll develop it if people not want to use it, and then if anyone else wants to take it on, it's up to them to take it on. So.
All right, Chris, I think we're going to go ahead and put that.
Okay. Any more questions? I'll stick around and we can
Let's give Chris a huge round of applause.